So here's another example of factoring trinomials. This one here, we're going to be dealing with some negative terms. Okay? So, same as before, we need to determine what our A, our B, and our C are. Okay? And the reason being is we want to find the factors of A and C and list them out in a column. So, the first one, factors of A, what are factors of 4?
1, 2.
Yeah, 1 and 4 and 2 and 2. Okay, and we set them up in a column so that we know that we'll be only taking numbers that are on top of each other. Then we look for values of C. Now, what are factors of 1? Yeah, just 1 by 1. Now, what's going to be important here is we have to create -1, which means one of these will be negative. We don't technically know which one yet, and we're going to work on that part. We know from before that we need the product of both of these to add up to our B value, which happens to be -4 in this question. So we're going to do some trial and error here. We're going to try 1 by 1 and 4 by 1, which is going to give us 1 and 4. Any combination make -4? No. And if we go across, we get the same numbers because these are both 1. We just get 4 and 1. So with this first column here, doesn't work in this case. So we eliminate. So we go to the second column, and the second column does work. We know 2 times 1 and 2 times 2 will work. Hold on. This is good. I've discovered that this doesn't work, but I went back and I looked. I actually wrote this question down wrong. So if this was the question, this would be unfactorable to us. We cannot factor this, okay? But I actually wrote this question down wrong, and it should be a value of 3 here, okay? Which means they need to add up to -3. So we need to backtrack a little, because I think in our first set, these values would have worked. So let's try those again. Does a combination of 1 and 4 equal -3?
No. Yeah,
What can I do to make this add up to -3? If I make it a -4, which makes sense because...
it would still equal...
That's right. If the 4 is negative, that means this number here I multiplied by had to have been negative, which is perfect. So when we go to check this, -1 times +1 is -1. So that worked out, and they both work here. They add up to -3. So these are our 2 columns. This is great. We know when we go to write our 2 columns out, the numbers in the first set of columns will be our first terms. So we'll have 4x and 1x, or x. And the numbers in our second column will be our second terms. Now, this is important. Because we multiply 4 times -1, they have to go in opposite brackets. So we have -1 over here, and we have the +1, oh, not 4, +1 in that bracket. Okay, so let's rewrite this all in black here. 4x is equal to, f of x equal 4x plus 1 times x minus 1. Just because on your notes your final answer will be in black. Okay? So we're going to use some concrete materials. They're known as algebra tiles to help us solve this. Now, in order to do algebra tiles, we still have to find 2 values that multiply to A times C, and those same 2 values need to add up to our B. So A times C in this case is -4, and B in this case is -3. So we need 2 numbers that multiply to -4 and add to -3. What are some factors of -4? 2. Well, 2 times 2 give us 3. What are they going to be? -1 and 4? -4 and 1. Now, this is important. So, these values here are going to tell us how many x tiles to use. Okay? We're going to need 4 negative x tiles, and we're going to need 1 positive x tile. I'm going to bring a positive x tile out. So, I'm going to rewrite my equation. It still starts with 4x squared, but the middle term has now been broken into -4x and +x. Okay? And the last term is still our -1. So this part here we're going to represent with algebra tiles, all of these values. So I have 4x squareds. So I'm going to take out 4. 1, 2, 3, 4. We have 4 negative x's. 1, 2, 3, 4. We have a positive x. And we have a negative 1. So these tiles here, we need to work on arranging them into a rectangular form. Okay? So in order to do this, I suggest we first work with the x squareds and the constant value, which is our negative 1. We put the constant at the corner here. Okay? So we've set this up. Now we have to see if we can fill in the rest of the space, because this has to be flush with our x values. Okay? So I'm obviously going to have to turn them around, some of them. Let's try moving them over. If this was a negative x, that fits. And then if we turn these around, we're left with 1 extra x. So what that means is this arrangement didn't work. I need to rearrange my x squareds. Okay? There's really only one other arrangement I can do with my x squareds, which is up and down. So I'm going to put them all on top of each other. And we're going to try moving the negative 1 to the corner of those, and then fill in the rest of the spots with the x values.
X minus 5. This is the other answer. 5x minus 2.
Now when we set up this case, all of our negatives have to be beside each other. So our negative here goes down, and our positive comes up. And we've now made a flush rectangle. So to count this out, what this actually looks like, we're going to count these values. This is the width of a 1. Okay? So we have a value of 1 here. And these are all the widths of an x. Okay? So we, in this case, if you look back up to our old answer, are going to have 4 x's and a positive 1, which if you rewrite that is 4x plus 1. And on this side here, we have an x, and we have the width of a 1, but because these are all negative, we have a negative 1. So we have x minus 1. Through algebra tiles, if you just look at the length and the widths, they give you the factors.